Hello, this is Mr. Stansbury. I'm going to take you through the 19H notes on changing shape. At the end of this, you should be able to say I can find intervals when a function is increasing and decreasing by observing a graph or if given the equation of the graph. All right, so let's jump straight into some examples. Excuse me. First one, example 12 from page 622. Says find the intervals where f of x is increasing and where it's decreasing. So again, it's pretty straightforward. It's just what it's asking for. It's like, when is this graph increasing? So this arrow is pointing down here, so you have to assume that this goes forever and ever down this way. So it's increasing all the way up to -1. Okay, so it's increasing when x, let's see, when x is, let's see, less than or equal to -1, it's increasing. Okay, and then from -1 to 2, it's decreasing. So it's decreasing from -1, put the x in the middle, to +2, and then x is less than or equal to 2, and x is greater than or equal to -1. Okay, and then it goes back to increasing for when x is greater than or equal to 2. So when x is greater than or equal to 2, it is also increasing. All right, and that's all there is to this one. Let's take a little video break, shall we? I don't know if I've ever seen a cat chase a dog like that, but anyway, let's take a look at our second and last example for 19H. Okay, find the interval where the following function is increasing and decreasing. So just like the previous one, except we don't have a graph. Okay, so there are a couple ways you can do this. One, you can do it with graphing calculator, or two, you can do it with, of course, since we're in chapter 19, derivatives. So first thing I'll do is show you on the graphing calculator. Okay, and again, I don't really particularly care which way you do this. If you're taking the IB test, you can use the graphing calculator on this. So anyway, so here's the equation, the function. So I'm just going to do a zoom standard and see what this thing looks like. So there's our graph. So it is decreasing. Basically what we want to do is just find the minimum there and the maximum there, and we just got to find the x values of each of those, right? So second, calculate, let's find the minimum. All right, so there's to the left, there's to the right, and let's see. Now we got 6.697 blah 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 e to the -7, so that means 0. So it is, let's see, decreasing when x is less than or equal to 0. So decreasing when x is less than or equal to 0. And then let's see what that maximum is, and that's the point from 0, so increasing when x is greater than or equal to 0 but less than or equal to, let's figure out what that other point is. So we're going to calculate the max there. All right, there's the left side, get it past the top. There's the right side. Excuse me, and that gives us that x is 2. Okay. All right, so it's increasing when x is greater than or equal to 0 but less than or equal to 2. And so that also means that it is decreasing after x is 2, right? So when it is decreasing when x is greater than or equal to 2. All right, excuse me. So that's how you do it with a calculator. Again, you can do the same thing with derivatives. So we've got, here's f of x, so let's find f prime of x. So 3 times -x is -3x. We subtract 1 from that and we get x squared. And then 2 times 3 is 6x. Subtract the 1, and we get 6x to the first. And again, remember this is a constant, x to the 0. So 0 times anything is going to give us 0, so that just disappears when we take the derivative. Okay, so here's our derivative, and then all you want to do here is we want to know when the derivative is 0, because that's when our tangent line here is 0. So it'll give us this x value, and it'll give us that x value. Okay, so 0 equals negative 3x squared plus 6x. So all I want to do here is factor. So let's see, we can get a negative 3 out of both of these. Let's see. Let's try that again. And so we get 0 equals negative, actually you can get an x out of both of these too, right? 0 equals negative 3x times, that's just going to leave us with x minus, oops, not 3, but 2. Right, so x would have to, in order for this to equal 0, x has to equal 0, or, and then this would be 2 minus 2 gives us 0. So those are our two places where the slope equals 0. And since this is a negative, it's a negative cubic, that means that our graph, we know that ends up going down. So it's basically, we know it's going to look something like something of this nature, right? So then we know that it is going to be decreasing all the way up until the first one. So it's going to be decreasing all the way from x, where x is less than 0. And it's going to be increasing from the 0 to 2. So that's this piece right here. And then it's going to decrease for the rest of that, and that is when x is greater than or equal to 2. All right? So you should now be able to say that I can find intervals when a function is increasing and when it's decreasing by observing a graph, or if given the equation of the graph. Okay? If you have any questions, please ask. Thanks.